Hi, welcome to my Phys2212 lab 3 report. In this lab, we are going to discuss the magnetic field of a bar magnet. Here's a brief introduction of my lab report. At the beginning, I will briefly talk about the key concepts and principles applied in this lab. And then I will talk about the experiment procedure and observations and results of my lab. After that, I will do a simple calculation model and the coding model. At the end, I will discuss the follow-up questions. Here are the principles and formulas we applied in this lab. We can use Biot-Savart law to calculate the magnetic field, and then we also use distance dependence formula to calculate the useful variable mu and n in the later part. So for the experiment setup, I simply put the bar magnet at one end of the east-west axis by zeroing the x component and place the ruler perpendicular to it. Then, following the lab procedure, I find the maximum x component and maximum y component to locate the magnetic sensor in my phone. For the part 1 of our experiment, we're going. I would need to find the desired magnetic field by moving my phone alongside x-axis, and I will record different d perpendicular distance to our Excel sheet. So I simply took the experiment for 3 times and took the average on it, and our Excel sheet automatically drew the linear equation on the graph for us. And this linear equation is important for us to solve n and mu in the later part. For part 2 of our experiment, we add a new axis in y direction, so that we can find out the magnetic field along the 45-degree axis at some distance d to a real-life measurement at the same distance d with my magnetometer. And here are the data I recorded for this part of the experiment. So for our experiment calculation, we'll use distance dependence formula to figure out n and k. Since we already have the linear equation here, we can simply calculate the k as 5.89 times 10 to the power of minus 7. And then we can simply substitute the unknown variable in our Biot-Savart formula to calculate mu is equal to 0.37. And in the experiment observation, when I find that when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. And as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. Here's my models. Here's my coding models. As I calculated before, the magnitude of mu is 0.37, so I simply replace the unknown number here, and then I use the Biot-Savart law to implement our formula function. Here I just simply set up our x-axis and y-axis, and I also created several arrows to show the magnetic field on different axes. And also here I used our coding model to calculate the theoretical magnetic field along the 45-degree axis, and compare the theoretical coding answer to our real-life measurement. I find the difference is pretty high, and this is because maybe there are extra magnetic field in my surrounding areas when I was doing the experiment. And here are the follow-up questions. So if we hadn't orient my experiment to compensate for the magnetic field on Earth, I would say the data I recorded will be much more different, and my result will be changed a lot, because like in different axes there will be extra magnetic field from Earth, And if I stick two identical magnets together, maybe the magnetic field will double, um, and as I move closer to our magnets, the um, measured magnetic field will be larger, and it will highly affect our lab results. And that's it. Thank you.